Hello everyone, this is PM Chellapandi here. First of all, I would like to welcome you to my today's session. In this session, we are going to discuss about the axioms of probability in details, right? These axioms of probability are the fundamental rules that define probability mathematically. All advanced topics like conditional probability, Bayes theorem, random variables, and distributions are built on these axioms. So, if you understand this axioms concept clearly, the rest of the probability becomes so easy, right? So, here in the next slide, we are going to recall some basic things, okay, that will help us to understand this concept clearly. So, first, an axiom is a basic rule or a principle that is accepted as true without proof, right? So, in mathematics, every theory starts from axioms, right? For probability theory, these axioms were formally introduced by Russian mathematics Andrei Kolmogorov in 1933. So his framework made probability even more strong mathematical subjects, right? So here, let us understand the empathy concept, okay, in axioms. So design thinking in probability, okay. So here, before discussing the axioms, let's recall three important terms, okay. The first one is sample space. So we usually denoted sample space in the capital letter S. Okay, here sample space means the set of all possible outcomes, right? So what are the possible outcomes? That is called the sample space. Let's come to the second important term is event, right? So we usually denoted event by the word capital A. So event is nothing but it is a subset of a sample space, right? So now we know very well what do you mean by sample space, okay. The subset of the sample space is called an event, right? Let's move to the third important term, that is probability. So we usually denoted probability by P of A, right? So here it is represented as a number or a number assigned to an event, right? So probability means it helps us to calculate the number of chances to be happened or to not to be happened. So to calculate that we use probability, right? So here the axioms define how this probability number must behave. So here there are three axioms. Let's discuss one by one what is saying in each axioms. Okay, in axiom 1, the condition is P of A is always greater than or equal to 0 for every even capital A, which means the first axiom says that the probability can never be negative, right? So why? Because probability represent number of chances or likelihood. So chance cannot be negative. So we know that very well. For example, probability of rain tomorrow. Okay, what is the answer? It may be 0.5 or 0.2 or 0.3, whatever it is, but it will never be minus 0.3, right? So and another example, what is the probability of getting 6 on a die? So definitely there must be some answer, but never be minus 1. So this minimum probability is the 0. Okay, now let us ideate this concept using design thinking concept. So how do you probability axioms aid in decision making, right? So there are three categories: risk assessment, game strategy, and weather forecasting. So here it is said, before that let's have some detailed something in detail about these three axioms. So in first axioms it is clearly saying so P of x is always greater than or equal to what? It is 0. So in the second axiom it is saying P of s is equal to 1, which means the probability of entire sample space is equal to 1. So that means something in the sample space must happen, okay. For example, If we toss a coin, either head or tail must be acquired, right? So P of head or tail is equal to always 1. This axiom ensures that probability is properly scaled between 0 to 1, right? So what is saying in the third axiom? So it is additivity, mutually exclusive events, right? So if A and B are mutually exclusive, then P of A union B is equal to P of A plus P of B, right? So here the third axiom is clearly saying if two events can't be happened at the same time, we simply add their probabilities. So these events are called mutually exclusive events. For example, when rolling a die, event A is equal to getting 2, even B is equal to getting 5. So you can't get both 2 and 5 at the same time, right? So this is what is saying in the third axioms, right? So now let's come to some important things, that is called how do probability axioms aid in decision making. So there are risk management and game strategy and weather forecasting. In these three major area, these axioms are playing a crucial role. So that is now the application of probability is probability that a student passes is 0.8. For example, in a class, the probability of students who ever have passed is 0.8, or the probability of students who ever had failed is 0.2. Pass and fail are mutually exclusive events. Okay, for example, when you add the probability of pass or fail is equal to 0.8 plus 0.2, what you will get, it is 1. Okay, this satisfies the second axiom. So why axioms are important in AA and engineering? So in engineering, machine learning models can be calculated using probabilities. So risk analysis uses probability values. Data science relies on probability rules. So if axioms were not defined properly, probability calculations would not be consistent. So axioms ensures that mathematical correctness, right? So here, in summary, it is say we can summary we can give a conclusion. So it is there are three axioms of probability. The first one, probability is never negative, never negative. The total probability equals 1. Probability of mutual exclusive events are added. So these simple rules forms the foundation of the probability theory, right? So understanding these axioms makes advanced topics much easier. So let's conclude this topic. Before that, here you can find the assessment questions. If you give the correct answer to these questions, which means you would have been understand about this concept clearly. Okay, you can try it. Now the next two, I have shared some reference links regarding this topic to gain more knowledge. So you can use this reference links for getting more knowledge. Thank you. So I hope this video will help you to understand what is axioms and where we are using these three axioms, how it is helping us in our real life, and how it is playing a crucial role in probability. So thank you so much. I hope you all have got a clear understanding of this concept. So I will meet you with another concept in the next video. Thank you.